Hey, I'm mainejason, and today I'm upgrading my lathe from Slippin to Grippin. Let's give it a try. The Southbend 10K lathe was originally designed to run with a flat leather belt drive, but I decided to run mine with a VFD in order to get instant control over speeds and feeds. Overall, it's been awesome, but there's one big problem. It's slipping where it should be gripping. In today's video, we're going to try to fix that by swapping the flat drive spindle pulley over to a V-belt pulley system. If we're successful, stalled spindles, scary chatter, and insanely slow feed rates should be a thing of the past. Let's give it a try. My Southbend 10K lathe is set up with a VFD, which directly drives the spindle with an adjustable V-belt. So far, this has worked out well, except when I need to part something off. Because the belt is riding on a spindle pulley that's designed for a flat leather belt, parting procedures often end up slowing down or stopping the spindle as the V-belt spins on the pulley. I've tried using some non-skid tape on the pulley surface, which works for a while, but it usually just wears off after a bit and I'm back to the belt slipping issue. Here I'm just taking the headstock off the lathe so I can bring it over to the bench to work on it. And here it is. One brand new well-used headstock with a V-belt pulley. When I was searching eBay for this thing, I was pretty surprised to find that I could buy an entire headstock equipped with a V-belt pulley for less than the cost of actually buying the pulley all by itself. As you can see, the unit I got was absolutely filthy, but I guess that's to be expected with these old, well-used parts. Dismantling these is a fairly easy process, a few screws here and there. Hardest part is remembering where everything goes back together. Here I'm removing the back gear so I can get the cover off and get better access to remove the spindle. Using a brass drift here so I don't mar anything. Everything comes apart fairly easily, just be sure to catch all the small parts so they don't drop to the floor and disappear, only to be found years later when cleaning the shop. That was the reversing gear being removed, and now I'm removing the take-up collar. It's always a good thing to remember to loosen the bearing cap screws, or you'll run the risk of damaging the bronze bearing surfaces when you take out the spindle. Finally, a few persuasive taps with a dead blow hammer. And then finally the spindle should pop free. You want to keep a hand on all the parts inside as you remove the spindle so they don't fall into the cavity. And make sure to grab the thrust bearing so it doesn't fall in as well. And our prize. A new addition to my shop is this small parts cleaner. I definitely wish I had this when I was restoring the lathe, as it makes things much easier and much less messy. I'll leave a link to this and the other tools that I use down in the description. If you like what you're seeing so far, please strike a like and subscribe to the channel. I'd really appreciate it, and it will give me the ability to bring you more content in the future. So here we have the original headstock on the bench, and I basically just retraced the steps from disassembling the old headstock. Take-up collar comes first. Now on my machine I've added a needle thrust bearing to the take-up collar to help with dialing out lateral movement in the spindle. We loosen up the bearing cap screws, and then with a few taps of the dead blow hammer, we're out. Again, remember, when doing this, make sure to hang on to all the guts inside so nothing drops away. Thrust bearing. installing everything back in the headstock can be a little bit tricky as the tolerances are very close. Just thread the spindle through each part slowly, not forgetting the thrust bearing before pushing the spindle all the way to the left side. You can see the mark that I made on the bull gear to indicate the keyway location. This needs to line up with the key on the spindle. It should slide in with a bit of resistance. If it doesn't, do not force it. That wire that I was pulling out is used to keep the oiler wick inside the large bearing clear from the spindle while it's being inserted. Finally, just reinstall the needle thrust bearing and the take-up collar. Check that everything spins freely. And success! Now back at the lathe, the new V-belt drive headstock is set into position. And the clamps are tightened up. And once again, check that everything spins freely. At this point, I'm adjusting the clearance of the spindle in the bearings. A brass bar is inserted into the spindle bore and pulled upward with about 75 pounds of force. I'm looking for about a 2/1000 on the test indicator. Note that this is a 10 micron indicator, so 2/1000 is about 50 microns or 5 lines on the indicator. Depending on the reading, I adjust the bearing cap screws to give me the clearance I'm looking for. The same adjustment is done on the back side of the spindle. I've read that the 10K lathe with bronze shell bearings should be adjusted to between 7/10 and 1/1000. But I've found with the age of my lathe that tends to be a bit too tight and the spindle does not spin freely. 2/1000 has been a good compromise and my results have been acceptable so far. Finally, the lateral movement of the spindle is adjusted with the take-up collar. I usually do this by feel and that has worked well for me. Reinstalling the V-belt is a simple matter of threading it through and engaging the tabs. This belt has worked great for me and I'll leave a link to it in the description below. With the belt in, the slack is taken up and the motor is locked into position. Moment of truth time. Turn it on and see if it runs. The initial spin up looks good, and I've filled the spindle oilers as some of the oil drained out when it was on the bench. Now I'm engaging and checking the back gears to make sure that everything runs properly, and it all looks pretty good. Now it's just a simple matter of installing the reversing gear assembly, the banjo, and the drive gears. Now here I'm doing a final check using the power feed, and everything seems to look great. And now the moment I've been waiting for. I chucked up some aluminum round stock in the 3-jaw and took a couple of cleanup passes. And then I went big. Parting with power feed. There's no slipping, there's no stalling, and a nice consistent chip coming off. Finally, I can part things off with my lathe without it taking hours of time and years off my life. That's it for today's video. So we gave it a try, and I couldn't be happier with the way things turned out and how my old lathe is performing. Please subscribe, strike a like, and let me know what you think down in the comments. Until next time, I'm mainejason. Get out there and give it a try.